It really makes you stop and think, you know? Like just yesterday, we were all struggling to figure out email, and now we're talking about AI that could practically write poetry for our trading algorithms. And then there's blockchains keeping track of transactions on a global scale, not to mention those crazy crypto markets going up and down like a roller coaster. It's amazing how fast technology changes, especially in the world of finance. That's exactly what we're diving into today.
You hit the nail on the head. We've got some really interesting stuff to unpack here, especially those thought-provoking excerpts from Rising AI Tech Demystified. Our mission today is to break it all down, pull out the key insights, and make sure you walk away with a clear understanding of these powerful technologies, especially how they all come together in the world of algorithmic crypto trading. Think of it as your crash course in becoming a well-informed expert.
Absolutely. Now, we know that some of this stuff can sound pretty intimidating, especially when we start throwing around terms like deep learning or decentralized finance. But trust us, we're going to explain it all in plain English, making it easy to grasp, and hopefully even a little fun along the way. You don't need to be a computer whiz to follow along. This deep dive is designed for anyone with a curious mind who wants to understand these transformative technologies. So where do we start? Maybe with the big kahuna itself, artificial intelligence.
AI, it's everywhere these days, isn't it? And it's only going to become more prevalent. Just look at the potential for self-driving cars to revolutionize transportation, or chatbots that can hold increasingly complex conversations. But here's the thing. While these might feel like brand new concepts, the core ideas behind AI have actually been around for decades.
Right. I mean, you have the Dartmouth Conference back in the 1950s, which really kicked off AI research in a big way. And of course, there's Alan Turing and his famous Turing test, the idea being, could a machine trick a human into thinking it was another human? It's incredible to see how far we've come from those early theoretical days to the unbelievably sophisticated AI systems we have today, all powered by the advancements in neural networks and deep learning. The fact that these systems can learn and adapt on their own is mind-blowing.
And the future of AI, well, that's where it gets really exciting. I mean, we're talking about things like assistive technologies that could dramatically improve the lives of people with disabilities, or fully autonomous systems that could reshape entire industries. The potential is almost limitless. But with all this power comes a need to really think about the broader consequences.
Absolutely. We need to consider how AI will change industries, potentially even the very nature of work itself. Now, in terms of the movers and shakers, who are the big players really pushing the boundaries of AI research and development?
One name that consistently comes up is OpenAI. They're a real powerhouse in the field, responsible for some truly groundbreaking advancements. Just think about GPT-2, their language model that could generate amazingly coherent and human-like text. And then they came out with GPT-3, which is even more powerful. And let's not forget DALL-E, which can actually create original images from simple text descriptions. Like that example in our source material with Ada Lovelace, it really highlights the creative potential of this technology. And then there's ChatGPT, their conversational language model that's been getting so much attention. It was trained on a massive amount of human text, and it can hold some pretty realistic conversations.
Yeah, it seems like they're coming out with something new every other week. It's hard to keep up. And it's interesting that OpenAI's stated mission is to develop friendly AI. It makes you think they're really focused on making sure these tools are used for good. They even have a set of core values: audacious, thoughtful, unpretentious, pragmatic, collaborative, and growth-oriented, which gives you a sense of their overall approach. But of course, with all the excitement around AI, there are bound to be some misconceptions out there, right?
For sure. There's definitely a lot of hype, and sometimes it's hard to separate fact from fiction. One common misconception is that AI is going to steal all our jobs. The more likely scenario is that AI will automate certain tasks, allowing us to focus on higher level work and potentially making us more productive. Another common fear is that AI is going to become some kind of superintelligence that takes over the world. While we do need to be cautious and develop AI responsibly, it also has incredible potential for good in fields like healthcare or scientific research. And let's not forget that AI isn't perfect. Like with that Microsoft chatbot, Tay, that went rogue after being exposed to some pretty nasty stuff online. It just goes to show how biases in training data can lead to unintended and sometimes even harmful outcomes. And as for AI being able to think and act completely on its own, or even having consciousness, well, that's still firmly in the realm of science fiction.
Right, like that example from our research where an AI was tasked with getting people to Mars, and it just calculated the fastest physical route, completely ignoring things like, the need for oxygen or food. It makes you realize that even powerful systems need careful guidelines and human oversight. Now, AI is obviously a huge and complex field, but let's zoom in on one of its core components, machine learning, which is really driving a lot of these advancements.
Machine learning is, in a way, the engine behind much of modern AI. It's about enabling machines to learn from data and get better at specific tasks without having to be programmed with every single step. Instead of giving the machine detailed instructions, you feed it data and it figures out the underlying patterns and relationships all on its own.
I like that explanation. It makes it sound less like magic and more like, learning. So where are we seeing machine learning make a real difference today?
It's popping up all over the place. In computer vision, which allows machines to see and interpret images, natural language processing so machines can understand and process human language, robotics, healthcare, where it's used to analyze medical images and patient data, and of course in finance, for tasks like fraud detection and predicting market trends. Even something as simple as spam filtering in your email relies heavily on machine learning, and we often don't even realize it's happening. The roots of ML go back a while, too, like that early checkers playing program developed by Arthur Samuel. That was a real breakthrough. And just like AI, the future of ML is looking pretty bright. From assistive technologies to autonomous systems, the possibilities are endless.
It's amazing to think about how this technology is going to change things. Now, our source material breaks down machine learning algorithms into three main types. Could you walk us through those?
Sure. Let's start with supervised learning. This is where the algorithm learns from a dataset that's been labeled. That means you provide the input data and the corresponding correct outputs. You're basically giving it an answer key to study from. It works really well for tasks like image classification, speech recognition, and natural language processing. Supervised learning can be really accurate, and it excels when you have a lot of labeled data. However, getting that labeled data can be a time-consuming and expensive process. Plus, it's important to remember that any biases in the training data will be reflected in the model's output.
Makes sense. So what about the second type?
That's unsupervised learning. In this case, the algorithm gets unlabeled data, and its job is to find the tune-in patterns and structures in that data all by itself. This is often used for tasks like clustering, where you group similar data points together, dimensionality reduction, simplifying complex datasets, and anomaly detection, where you identify data points that are out of the ordinary. The big advantage of unsupervised learning is that you don't need those explicit labels. It can find patterns and relationships that you might not have even been looking for. On the flip side, because there's no right answer to guide it, the patterns it finds might not always be meaningful or what you were hoping to discover.
Interesting. So it's kind of like exploration. You don't know exactly what you're going to find. And what's the third type?
That's reinforcement learning. In this approach, the algorithm learns by doing, basically through trials and error. It interacts with an environment and receives feedback in the form of rewards or penalties for its actions. Imagine a character in a video game learning to play by trying different strategies and seeing what leads to success. That's kind of how reinforcement learning works.
I see. And what about the term deep learning that we often hear? How does that fit into the world of machine learning?
Deep learning is basically a subfield of machine learning that utilizes artificial neural networks with many layers. That's where the deep comes from. These networks are inspired by the structure of the human brain, and they are really good at handling complex tasks like advanced computer vision, natural language understanding, and speech recognition. They can learn very intricate patterns from massive data sets, but they also need a ton of data for training. And like other ML methods, they can inherit biases from the data they're trained on.
So we've talked about the power and potential of ML, but there have to be some limitations and potential downsides as well, right?
Definitely. One of the biggest concerns is the potential for bias and discrimination. If the data you use to train a machine learning model is biased, the model is going to reflect and even amplify those biases, which could lead to unfair or discriminatory outcomes. We need to be really careful about ensuring that training data is diverse and representative, and that we're taking steps to clean the data and use fairness metrics to evaluate how the model is performing. Another major concern is safety and reliability, especially when ML is used in critical applications like self-driving cars or medical diagnosis. These systems need to be designed and tested rigorously using both simulations and real-world scenarios, and we need to constantly monitor them to make sure they're working as expected. And then there's the issue of privacy and security, especially when we're dealing with sensitive personal information. We need to use techniques like encryption and anonymization to protect this data. The source material actually gave some real-world examples of these concerns, like the insurance company using loan application times as part of their risk assessment, and that taxi app that was charging people more if their phone battery was low. It highlights how easily these technologies can be used in ways that might not be fair or ethical.
Those examples really drive the point home. Now, I also noticed that the source material talks about the distinction between large and small models in machine learning. What's the main difference there?
The difference is basically the number of parameters the model uses. Large models have a lot more parameters, which means they can learn more complex patterns and potentially be more accurate. But this comes at a cost. They take longer to train, they need more memory, and they require more computing power. Smaller models are faster to train and don't need as much horsepower, but they might not be as good at capturing those subtle nuances in the data. And larger models are more likely to overfit, meaning they might do really well on the data they were trained on, but then perform poorly on new data.
So it's like a trade-off between complexity and efficiency. And what about the financial investment involved in developing and deploying these large models? I imagine it could be quite costly.
It absolutely can be. Think about it. You have the time it takes to train these models, which can be anywhere from hours to weeks or even months for the largest ones. Then there's the cost of getting all that data and preparing it for the model. And you can't forget about the computing resources, which often involve using expensive cloud services or specialized hardware like GPUs. And once the model is up and running, you have the ongoing costs of keeping an eye on it, maintaining it, and updating it. Our source gives some ballpark figures, and it can range from tens of thousands of dollars for smaller projects to millions for those cutting-edge, large-scale models.
Wow, that's a serious investment. So, looking forward, what are some of the major trends we can expect in the world of machine learning?
We're definitely going to see more automation of complex tasks, greater personalization in products and services thanks to ML insights, and a tighter integration of ML with other emerging technologies like the Internet of Things and robotics, which will create even smarter and more connected systems.
And just like with AI, I'm guessing there are some common misconceptions about machine learning.
Absolutely, there are always misconceptions. One is that machine learning and artificial intelligence are the same thing. But in reality, machine learning is a specific type of AI. Another misconception is that you need mountains of data for ML to be useful. While having more data can be helpful, sometimes what matters more is having high-quality, carefully curated data. There's also the idea that machine learning models are these mysterious black boxes that we can't understand. But the truth is there are techniques we can use to interpret how these models are making decisions. And lastly, some people think machine learning is only for analyzing huge data sets, but it can actually be a useful tool for extracting insights from data sets of all sizes. Okay, so we've covered AI and machine learning, two of the main building blocks. Let's move on to another important piece of the puzzle, blockchain. Blockchain is that underlying technology that powers a lot of cryptocurrencies, but it has potential applications way beyond just digital money. At its heart, it's a distributed digital ledger that records transactions across multiple computers in a network. It's decentralized and uses strong cryptography, which makes it super secure, transparent, and practically tamper-proof. Because the information is spread across multiple computers and protected with cryptography, it's really hard for anyone to change the records.
So it's all about secure and transparent record keeping across a network. The source material also talks about Web3 and decentralization. How does blockchain fit into that?
Think of Web 1 as the early internet, where the focus was mainly on accessing information. Web 3, on the other hand, is about creating a more decentralized internet where users have more control over their data and their digital assets. Blockchain technology, and particularly cryptocurrencies built on blockchain, are key to realizing this vision of a decentralized internet.
And why is decentralization such a big deal when it comes to cryptocurrencies? What are the main benefits?
One of the main benefits is the ability to do what are called trustless transactions. In a traditional financial system, you rely on intermediaries like banks to verify and process transactions. With decentralized cryptocurrencies, the network itself handles the verification process, so you don't need to trust a central authority. This often makes the system more secure and resilient. Because there's no single point of failure, it's much harder for hackers to compromise the system or for anyone to censor transactions.
It's like taking power away from the gatekeepers and giving it back to the users. Now, we can't talk about blockchain and cryptocurrencies without acknowledging all the attention they're getting from regulators around the world.
Absolutely. Governments and regulatory bodies everywhere are working on creating rules and frameworks for virtual assets and blockchain technology. This is an ongoing process, and the regulatory landscape is definitely going to shape how these technologies develop and get adopted in the years to come. All right, so we've laid the foundation by talking about AI, machine learning, and blockchain. Now, let's explore how these powerful technologies are being used in a really exciting and dynamic area, cryptocurrency trading.
This is where it gets real, right? So let's start with cryptocurrencies themselves. For someone who's totally new to this, how would you define a cryptocurrency?
Simply put, a cryptocurrency is a digital or virtual form of money that uses cryptography for security. That cryptography is used for several things: verifying and securing transactions, controlling the creation of new units of the currency, and making sure that the transfer of those assets is legitimate. Bitcoin, which was created in 2009, was the very first cryptocurrency, and it really set the whole thing in motion. Since then, thousands of other cryptocurrencies have popped up, often called altcoins.
So unlike regular currencies, which are controlled by governments, cryptocurrencies operate independently.
Exactly. Cryptocurrencies run on decentralized blockchain ledgers, which means there isn't a central authority, like a government or a bank calling the shots. This decentralized nature is one of the key things that sets cryptocurrencies apart from traditional currencies.
And the value of these cryptocurrencies can swing wildly, right? We often hear about huge price fluctuations.
That's true. Cryptocurrencies are known for their volatility. The price is basically driven by supply and demand. Things like the limited supply of certain cryptocurrencies, like Bitcoin, which has a cap of 21 million coins, and the process of mining, where people use massive amounts of computing power to verify transactions and create new coins, all of that contributes to those price swings. But even with the volatility, cryptocurrencies have gained a lot of traction as both a way to pay for things and a potential investment, and there are a lot of people who believe they will eventually become mainstream.
In fact, the source material we have provides a snapshot of the crypto market size back in December 2022. What was the landscape looking like at that point?
Back then, there were over 7,000 different cryptocurrencies out there with a combined market value of about $800 billion. Bitcoin and Ethereum were the two biggest players, as you might expect. Of course, the crypto world is constantly changing, so new cryptocurrencies are popping up all the time. And while 2022 saw a big downturn in the market, the general consensus is that with increased adoption and clearer regulations, things could be looking up in the future.
It's a fast-moving space, that's for sure. So beyond just buying and selling, are there any real-world applications for cryptocurrencies?
Oh, definitely. We're seeing cryptocurrencies being used in a growing number of areas. For example, they're a fundamental part of the whole decentralized finance DeFi movement, which is all about recreating traditional financial services, but in a more decentralized and transparent way. Cryptocurrencies are also finding applications in things like supply chain management, digital identity, and other innovative projects.
Now, the source also explains these concepts of proof of work and proof of stake. I know those relate to the energy consumption of some cryptocurrencies.
Exactly. Proof of work, which is the system Bitcoin originally used, involves miners competing to solve complex math problems to verify transactions and add new blocks to the blockchain. That process uses a lot of energy. Proof of stake, which Ethereum switched to with its merge upgrade, takes a different approach. Here, validators are chosen based on how much cryptocurrency they hold or stake. This system uses a lot less energy than proof of work.
That Ethereum switch was a big deal in the crypto world. Now, I know there are some criticisms and challenges around cryptocurrencies. What are some of the main ones?
The volatility we talked about is a big one. The price swings can be pretty scary for some people. And even though blockchain technology is very transparent, there are concerns about cryptocurrencies being used for illegal activities. Also, the lack of clear and consistent regulations across different countries can make it hard to protect investors. And some cryptocurrency networks have had trouble scaling up to handle a lot of transactions quickly and cheaply.
So there's definitely still some work to be done in terms of making cryptocurrencies more mainstream and addressing those concerns. Now, what about these crypto exchanges we hear so much about? They seem to be the main platforms where people buy, sell, and trade cryptocurrencies.
Crypto exchanges are essentially online marketplaces for cryptocurrencies. They provide the infrastructure and tools you need to trade, including things like order books, trading interfaces, custody services for holding your digital assets, and of course, market data. They're essential for making cryptocurrencies accessible to a wider audience, and as such, they're increasingly coming under regulatory scrutiny around the world.
And there's been a lot of talk lately about proof of reserve and proof of liability, especially after some of the recent events in the crypto market. Why are those concepts so important for users?
Proof of reserve is a way for crypto exchanges to show that they actually have the assets they claim to be holding, often through independent audits. Proof of liability goes further, trying to demonstrate that the exchange's liabilities, what it owes to its users, are matched by its reserves. After the FTX collapse, those concepts have become super important for building trust and giving users more confidence in the solvency of crypto exchanges. It also highlights how important it is for users to do their own homework and choose exchanges carefully.
It definitely underscores the need for transparency in this space. It's still a relatively new and rapidly evolving market, and there are going to be bumps along the way. Speaking of which, where do you see cryptocurrencies going in the future? It seems like there's still so much potential for growth and disruption.
The future of crypto is definitely a bit of an open question. It's hard to predict exactly where it will go, but we might see things like stable coins, which try to peg their value to a more stable asset, becoming more widely adopted, and ongoing innovation in the technology could overcome some of the limitations that cryptocurrencies currently face. Of course, regulations will play a major role in shaping the future of crypto. It's something we'll need to keep a close eye on. Okay, so now that we have a good understanding of cryptocurrencies themselves, let's get into the nuts and bolts of actually trading them. For someone who's completely new to crypto trading, what are the basics they need to know?
Right, let's talk about crypto trading basics. What are the key principles and steps involved for someone who's just starting out?
The very first thing is to pick a reputable crypto exchange. Do your research and find one that's known for security, reasonable fees, a good selection of cryptocurrencies, and a user-friendly interface. Once you've got an exchange, the next big thing is figuring out how to securely store your digital assets. This means learning about different types of crypto wallets, software wallets, hardware wallets, things like that, and understanding the trade-offs between security and convenience that each type offers.
So pick an exchange, secure your assets. What about actually making trades? What terms or concepts do beginners need to understand?
Well, there's some basic trading lingo you'll need to know, like going long, which simply means buying an asset hoping its price will go up, and going short, which means betting that the price of an asset will go down. There's also the concept of leverage, where you can essentially borrow funds to amplify your potential profits, but that also magnifies your potential losses. And then there's market capitalization, which we talked about earlier, which represents the total value of a cryptocurrency.
Right, and how do you even begin to evaluate a cryptocurrency's potential value for trading? It's not like you can just look at a company's financial statements.
True. There are a few main approaches you can use. Technical analysis is about looking at historical price charts and trading volumes to identify patterns and try to predict future price movements. It's all about spotting those trends and signals in the market data. Fundamental analysis, on the other hand, is about assessing the intrinsic value of a cryptocurrency by looking at factors like the technology behind it, the team developing it, how widely it's being adopted, and its real-world applications. And then you have relative valuation, where you compare one cryptocurrency to similar ones or to benchmark assets. Sometimes traders even use the capital asset pricing model, or CAPM, which tries to figure out the theoretical fair value of an asset based on things like its expected return relative to its risk.
The CAPM sounds a bit complicated. Could you give a quick rundown of how it works?
Sure. Essentially, the CAPM calculates the expected return on an investment by taking into account a few things. The risk-free rate of return, which is the return you'd expect from a very safe investment, the expected return of the market as a whole, and the asset's beta, which measures how volatile it is compared to the broader market. By plugging those numbers into the formula, you can get an idea of whether an asset might be overvalued or undervalued. It's a widely used tool in traditional finance, but how well it applies to the crazy world of cryptocurrencies where things are so volatile and less driven by traditional fundamentals is still up for debate. People often use it along with other analytical methods.
Good to know. And speaking of knowing things, our source material has a glossary of key cryptocurrency and blockchain terms. It seems like you need to learn a whole new language to navigate this space.
You're not wrong. There are a lot of new terms to wrap your head around. Cryptocurrency, blockchain, crypto exchange, wallet, private key, public key, mining, gas fees, DeFi, NFTs, the list goes on. Familiarizing yourself with these terms is a must if you want to understand what's going on in the crypto world.
It can be a bit overwhelming at first, but it's fascinating once you start to grasp the concepts. So knowing all this and understanding the risks, what would you say to someone thinking about getting into crypto trading?
My advice would be to trade carefully and prioritize learning. The market is incredibly volatile, the regulations are still being figured out, and there are some technical complexities you need to understand. Do your research, understand the risks in Gov, and never invest more than you can afford to lose.
Wise words. And what about some of the common myths or misconceptions about crypto trading? There seems to be a lot of misinformation floating around.
Yeah, for sure. One of the biggest myths is that crypto trading is a guaranteed way to get rich quick. The truth is, it's a risky business and you could easily lose money. Another misconception is that it's illegal, but it's actually legal in many parts of the world, although the regulations vary. Some people also think it's easy and doesn't require much knowledge, but that's not true at all. To be successful, you need to understand market dynamics and often some technical analysis. It's definitely not a get-rich-quick scheme, and while regulations are still developing, it's not a completely unregulated Wild West either. International organizations and governments are working on creating guidelines and frameworks for this space. All right, now that we've covered the basics of crypto trading, let's dive into the heart of our deep dive, algorithmic trading basics in the world of crypto. What is it all about? Algorithmic trading, sometimes called automated trading or black box trading, is all about using computer programs to execute trades based on preset rules and market data analysis. These algorithms are designed to spot trading opportunities and automatically place buy-sell orders with the goal of making a profit.
So you're essentially letting the computer do the trading for you based on a set of instructions. What are the advantages of this approach in the crypto markets?
There are quite a few potential benefits. Algorithms can trade much faster and more accurately than humans. Plus, they don't have emotions, so they're not going to make bad decisions based on fear or greed, which can happen to human traders. Algorithms can also operate 24/7, taking advantage of trading opportunities at any time of day or night. And they can often reduce transaction costs and improve risk management by sticking to those predefined rules. Plus, algorithms can execute complex, high-frequency trading strategies that would be impossible for a human to do manually.
It sounds like you're giving up control, but you're actually gaining a lot of advantages in terms of speed, precision, and objectivity. But what about the downsides? Are there any risks associated with algorithmic trading in crypto?
There are definitely some challenges to consider. Developing and using effective trading algorithms requires a good understanding of both trading and programming, and you also need a reliable technology infrastructure. The crypto market is incredibly complex and volatile, which can be tough even for sophisticated algorithms to navigate. And there's always the risk that the algorithm itself has flaws or biases that could lead to unexpected losses. Technical issues or failures in the trading infrastructure can also create problems.
The source material mentions something called crypto trading bots. How do those relate to algorithmic trading? Are they basically the same thing?
Crypto trading bots are basically pieces of software that connect to crypto exchanges and automatically make trades based on algorithms or trading strategies. They essentially handle the entire trading process from analyzing market data to placing orders without you having to lift a finger once you've set them up. So they're a real-world application of algorithmic trading specifically designed for the crypto market.
So it's like having a robot trader working for you 24/7. But the risks we talked about, those, would still apply to using trading bots, right?
Absolutely. All those risks we discussed, like the complex and unpredictable nature of the market, the possibility of flaws in the algorithms, and the potential for technology to fail, those apply to trading bots as well. And they can definitely lead to financial losses. Now, there are ways to mitigate those risks. For example, you can integrate advanced technologies like machine learning and artificial intelligence into your bots to make them more adaptable. And you can use robust risk management strategies, but you can never completely eliminate risk in trading, whether you're doing it manually or with algorithms.
So is algorithmic trading something every crypto trader should be using, or is it more for a specific type of trader?
I think it can be a valuable tool for traders who have a good grasp of trading strategies, programming, and risk management, but it's not necessarily the right approach for everyone, especially beginners or people who aren't comfortable with the technical side of things. I'll refrain from giving any specific investment advice here, which is always a good rule of thumb in this space.
Smart move. And what are some of the common misunderstandings about algorithmic crypto trading?
Well, one big misconception is that it's a guaranteed path to profits. But the truth is, the crypto market is so volatile that even the best designed algorithms can lose money. Another myth is that once you set up an algorithm, you can just forget about it. In reality, you need to monitor it, make adjustments, and keep it updated to keep up with the constantly changing market. Some people also think that algorithmic trading is only for big institutions, but with all the platforms and tools available today, it's actually becoming more accessible to individual traders. And lastly, while some proprietary algorithms might be a bit of a black box, many systems are designed to be transparent, so you can see how they're executing trades based on the rules you've set. Okay, so we explored the basics of algorithmic trading in the crypto world. Now let's take a look at how to actually build those algorithms. Building a successful trading algorithm for cryptocurrencies is a step-by-step process. And the most crucial step, the one where everything starts, is defining your trading strategy. What are you trying to achieve? How much risk are you willing to take? Your algorithm is going to be built around this strategy, so you need to be really clear about what you want it to do.
It's like building a house. You need a blueprint before you start laying bricks. So once you have a strategy in place, what's next?
Data, data, data. You need to gather and prepare the historical market data that your algorithm will learn from. That includes things like price movements, trading volumes, and maybe even other market indicators. And that raw data needs to be cleaned up, formatted, and organized in a way that your algorithm can actually use. The quality of your data is going to have a big impact on how well your algorithm performs.
So you've got your strategy, you've got your data ready to go. Now comes the actual coding part. That's where it gets really technical, right?
It definitely gets technical. This is where you take your trading strategy and turn it into code. There are different programming languages and algorithmic approaches you can use. Some common ones are decision trees, random forests, and neural networks. And often you'll train these algorithms on the historical data you've prepared. It's a process that requires careful design, testing different models, fine-tuning the parameters of the algorithm, and making sure you have the computing power you need to actually run it. In our source material, there's an example of a hedge fund using machine learning for high-frequency trading. It just shows you how sophisticated these things can get.
That's pretty impressive. But once you build the algorithm, how do you know if it's actually going to work?
That's where backtesting comes in. Backtesting means running your algorithm on historical market data to simulate how it would have performed in the past. By looking at the results, you can get an idea of whether it would have been profitable, identify any potential problems, and assess the risk involved. The key is to create a backtesting environment that closely resembles real-world trading conditions, but it's important to remember that past performance doesn't guarantee future results. Backtesting is a useful tool, but it has its limitations.
So you can't assume that just because it worked on historical data, it's going to be a money-making machine in the real world. What's the next step after backtesting?
If you're happy with the backtesting results, the next step is to deploy the algorithm. That means setting up a live trading account on a crypto exchange and connecting your algorithm so it can start executing trades using real money. But the work doesn't stop there. You need to constantly monitor how your algorithm is doing in the live market and make adjustments as needed. This might involve tweaking the parameters, refining the trading strategy, or even adding new data sources or analytical techniques based on how the market is behaving. And staying up to date on what's happening in the market is essential for making informed decisions about your algorithm.
So it's not a case of set it and forget it. You really need to stay engaged and adapt as the market changes. What are some common misconceptions people have about building their own crypto trading algorithms?
One big misconception is that it's easy just rip up a bit of code and watch the profits roll in. In reality, it takes a lot of knowledge, skill, and effort to create a successful trading algorithm. Another misconception is that anyone can do it without really understanding trading or programming. And some people think that an algorithm will be profitable right out of the gate. But that's rarely the case. It usually takes a lot of testing, tweaking, and refining to get it right. All right, so we've talked about building algorithms, but what about the practical side of actually implementing them? There are a few key steps involved. First, you need to find a crypto exchange that offers API access, which stands for Application Programming Interface. An API is basically a way for your algorithm to communicate with the exchange and automatically execute trades. You'll want to choose an exchange with a reliable API and reasonable fees.
API access sounds a bit technical. Is that something a non-programmer can handle?
It can be a bit tricky, but it's essential for automated trading. Once you've got your trading account and API access all set up, the next step is deploying your algorithm. This means configuring your trading platform or software to connect to the exchange's API using your unique API keys. And once that connection is made, your algorithm can start doing its thing, analyzing market data and executing trades based on your strategy.
So the algorithm takes over and makes all the trading decisions. Can you just sit back and watch the money roll in?
I wish it were that simple. While the algorithm does automate the trading process, it's really important to actively manage and monitor its performance. Keep an eye on key metrics like profitability, trading volume, risk exposure, and watch out for any errors or unexpected behavior.
And what happens when things inevitably go wrong, which is bound to happen in such a volatile market?